Hello and welcome to another lecture on the fundamental of mechanics. In our previous videos, we'll be able to learn about a force, its effect on the body, its classification, and its components. Well, in this video, we are going to be learning about a force system. Let's get started. A force system is a group or a collection of forces acting on the body in more than one plane. Well, this means that when there is more than one force acting on any body, as long as there are more than one, the collection of those forces acting on that particular body is what is called the force system. Now, according to the lines of action, the force system are classified as follows. 1. A collinear concurrent coplanar force system, a concurrent coplanar non-parallel force system, a coplanar parallel force system, and a coplanar non-concurrent non-parallel force system. Now, what does this mean? To understand them, basically, we have to look at each term. When we say something is collinear, we mean something is acting on a straight line. And when we say something is concurrent, we mean that something is intersecting at a particular point. And when we say something is coplanar, we mean they are acting on a particular plane. So if we go back to the classification of forces, I will look at the first one there that says a collinear concurrent coplanar force system. So it means that the forces are acting on a straight line, they intersect at a particular point, they are acting on a particular plane. That is for the first type of force system. And then if we look at the second one, a concurrent coplanar non-parallel force system, it means that the forces acting on that body are all intersecting at a particular point. They are all acting on a particular plane and they are not parallel to each other. When we say a coplanar parallel force system, we mean they are all acting on a particular plane and they are parallel to each other. When we say something is coplanar, non-parallel, non-concurrent force system, we mean that they are all acting on a particular plane, they are not intersecting at any point, and they are not parallel to each other. Now, let's look at some basic terms that we must know before we can be able to solve any problem in mechanics. And they are one, a line of action. When we say line of action, it's an imaginary line that shows the path where the effect of a force is felt the most. It's also the path to which the body will move that is under the influence of that force. The line of action is a straight line in the direction with the force. We have the second one, a free body diagram. A free body diagram is a skeletal frame of a body that is used to show the places where the forces, the movements and reaction of the body are on the body. Number 3, transmissibility of force. Now, there are some problems in mechanics that will require us to apply the principle of transmissibility. Now, let's consider the figure shown below. Let's consider a push force being applied to a body at point A. This force, this push force, can be replaced by a pull force at point B of the body along the same line of action and must be in contact with the body. Now, this push force and this pull force, they both have the same effect on the body, and they both will cause the body to move in a particular direction because they are both acting on the same line of action and they are both in contact with the body. Now, let's look at a point and distributed load. A point load is a force applied at a single point on a body, while the distributed load are those loads that are applied over a given distance or area of a body. In reality, all loads are basically distributed loads. Why? Because all loads are matter, and matter is anything that has mass and occupies space. But the reason why we use the point load in our calculations in mechanics is because it is more easier to calculate with. There are basically two types of distributed loads. We have the uniformly distributed loads and the non-uniformly distributed loads. In our next videos, we will show you how to calculate or turn a distributed load into a point load for easy calculation. Now let's look at what a beam is. A beam is a horizontal member for carrying or supporting vertical loads. Types of beam: we have a simply supported beam. This is the type of beam that has two supports, simple supports at both of its ends, while a overhanging beam is a simple beam also that its end is extending up over its supports. Then a cantilever beam has one end mounted or fixed to a wall and the other end is free. A continuous beam is a beam that has more than two supports, while a fixed and built-in beam is a beam that has both of its ends fixed to a wall. Now let's look at support reactions. Now these beams are supported, as we saw in the types of beam. They are all supported with either fixed to a wall or with a simple support. And according to the third law of Newton, it says that to every action there's an equal and opposite reaction. So to these supports, they are going to have reactions acting to the beam. The types of support determines the types of reactions that we have. For a simple support, which is a knife edge or a roller, they have only one reaction, which is a vertical reaction. Then for a pin support or a hinge support, this type of reactions they produce both a vertical and a horizontal reaction, that they produce two reactions. While for a fixed support beam, they produce a vertical, a horizontal, and a moment reaction, that they produce three reactions. Now, to solve anything in mechanics, we use some formulas that you will need to solve. When solving in statics equilibrium, in statics mechanics, we use three formulas, which is: one, the sum of forces in the x direction is equals to 0, and the sum of forces in the y direction or in the vertical direction is equals to 0, and the sum of moment is equal to 0. Then if the body is not in equilibrium, or we have to look for the resultant, the sum of forces in the x direction is equal to the sum of forces is equal to the resultant force in that x direction, and the sum of forces in the y direction is equal to the resultant force in that y direction, and the sum of moment at a point is equal to the moment, is equal to the resultant moment at that particular point. Now, to get the total resultant of the force acting on the body, the resultant force will be equal to the square root of the sum of forces in the x direction square plus the sum of forces in the y direction square. They are all in the square root, and this resultant will be acting at an angle, as you can see in the diagram. to be acting at an angle which is, and to get that angle, it is tan theta x, that's in the x direction, that this angle is joining to this x plane, and is equals to sum of forces in the y direction over sum of forces in the x direction, using your Pythagoras theorem as stated in our previous videos. And that will be all for now. Let's take a recap on what we have done so far. In this video, we have treated the force system, and we have been able to see the classifications of a force system. We have been able to learn about some basic terms, which are the free body diagram, the line of action, the transmissibility of a force, the difference between a pin load and a distributed load. I've also been able to learn about a beam, the types of beam, and the types of reactions that are formed at the various supports of a beam. Well, in our next video, we're going to be treating some basic problems that are pertaining to this topic. Until next time, keep learning, and remember, practicing only makes you better. Don't forget to like, subscribe, and hit the notification bell so you get notified when next we make an upload. Thank you for watching.